You really need the mental illness of treating this like an autonomous vehicle where you can't mess this up. And it just so happens that it's a significantly easier problem to determine if your door handle is defective than doing all of that processing and then saying, can this vehicle move forward?
Matt, coffee, tea, or something else? What fuels your mornings?
Oh man, right now I've got my cup of coffee. It's 10 a.m. our time, and this is cup number 4.
Already?
I'm a big, drink a gallon of coffee a day kind of guy, yeah.
Nice. Well, from the day you had yesterday that you just shared with me, that there's no surprise that you probably need extra. When you were a kid, what did you think you'd grow up to be?
I actually thought I was going to be Indiana Jones was who I wanted to be.
A specific person as well.
Travel the world, be a Latin dork, yeah.
That's cool. That's cool. So I'm assuming one of your favorite movies when you were a kid.
Oh my gosh, yeah. I mean, Star Wars as well. Really anything with Harrison Ford. Big fan.
Nice. I was Bruce Willis.
Nice.
Yeah. What's one technology you can't live without?
This is so silly, but I am honestly amazed at water bottles. I cannot live without this Nalgene. I will drink. Yeah, exactly. So trivial, but also so important to just not, being under the weather with all the travel that we do for work and things like that.
Definitely relate. And if you could fast forward 10 years and see one impact that your work's made on the world, what would you want that to be?
10 years from now, what I would love to see is a dramatic amount of manufacturing that takes place in the US using the bucket system, and that enables more people doing more complex tasks, and stripping away the deeply, deeply crappy aspects of manufacturing that come with quality inspection.
Awesome. Welcome to Machine Minds, everyone. I'm your host, Greg Terusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Matt Puchalski, founder and CEO of Bucket Robotics. Thanks for being on the show today, Matt.
Thanks for having me, Greg. I'm really excited to chat with you.
Pleasure. Let's jump into it. So you've spent time in your career across robotics, autonomy, startup world, etc. What originally pulled you into this space?
That's a great question. So I was very lucky to do my undergraduate at Georgia Tech, where I studied electrical engineering. And I was lucky enough to be a co-op at Michelin in Greenville, South Carolina, where you alternate between school and work. And so I worked in 2 different departments there, advanced quality systems in manufacturing and their test track in Lawrence County, South Carolina. And so, it's a lot of themes come from those formative years of, working in quality, working on vehicles. And that sort of started me down automotive, which led to autonomy, and then from autonomy to here at Bucket.
Very cool. And that co-op program, was it like that 6-month co-op that they do, or was it, you went back twice during your degree? How did it work?
Yeah. So Georgia Tech is huge on, Schillingford. I'm not sponsored by, but go Jackets. I had a great time. It's a huge, something like 40% of the undergraduate community does a co-op at Tech, where
Nice.
so I started my fall semester of my fall semester of my third year was my first co-op rotation in South Carolina, being paid to work. And then spring semester I came back, went to work at the test track that summer, and so you alternate, which is a really, really unique, when you're 19 years old, it's a great break from, electrical engineering, and then you get to go work in the real world and realize, oh, cool, okay, weirdly, why does MATLAB matter so much, but all of this math that I just did doesn't, right? And then you go back and you take some more classes and oh no, I get it now. That's what that math was for. Oh, amazing.
Very cool. Yeah. I guess that's especially for people that either haven't had that visibility prior to choosing their major, or that it's their first world experience within engineering in general, because no one from their family's been in it and stuff like that. It's like so valuable to help see how it's applied to the real world.
Exactly, exactly.
Yeah.
I was so lucky. I was actually just talking to somebody. Had to change the tires on my car a few days ago, and still rocking the Michelin's. They're
It's
great.
there. It's there. It's foundational for you.
Exactly, exactly.
Was there a specific moment where you realized that you wanted to build a company and not just carry on being an employee or part of one?
Yeah, so the spark had been there since the very beginning of my engineering experience.
Mm.
And again, it goes back to Michelin of I am so thankful for the time of being able to see what advancements look like and what projects get funded or don't get funded. And then more importantly, see the types of problems that direct line operators had, and those were always the things that I wanted to go super deep on of okay, cool, engineering says that this will make us 10% more efficient, but when you ask this operator who's been here for 30 years, what they actually need is to stop walking across the facility to grab a clipboard because they're spending most of their time, right? It's like, what? Say more about that, please. Let's go deeper on that. And so, as again, to your point, as you learn when you're in a large company, things get funded for different reasons, different priorities. There's, I hate the word politics, but like, people are universal of like, what can we actually draw a line on? And so, being able to work inside of systems and make people's lives better, and do it in a way that goes beyond just one shift or one sprint for 3 months was something that like there was always a hunger there, and as I went further in my career, the answer is through starting my own company.
Love that. And before starting Bucket, were there like super valuable lessons that you picked up along the way that directly shaped how you're building today?
I am so thankful for all of my life experiences, starting from my very first job in high school, working at a farm stand, dealing with customer relations, to then my other high school job as a camp counselor, trying to wrangle children, right, through working in manufacturing and seeing what actually matters and what doesn't. But then the thing that I spend a lot of time thinking about now was my time in self-driving cars and building a reliability team for fleets of vehicles deployed across multiple continents where, robots or self-driving cars are out there in the world, and they're just as vulnerable to things like birds pooping on their sensors or connectors failing, right? Like they're the bleeding edge of the future, but like they still get affected by potholes. That's just how, reality works. And so how do you build a system to help the operators who were in the vehicle in that moment, and then, build processes so that way you don't have this impact a whole fleet of vehicles. These are lessons that I learned on the job, and now I get to apply in a much more specific domain, but in manufacturing at Bucket.
Nice. So let's switch gears and talk about Bucket Robotics. Was there, or what was, if there was one, the like aha moment behind the company, and what problem did you see that others were missing?
Yeah. Oh, that's a great question. So like I said, spending time at Uber and Argo and Stack AV inside of autonomous vehicles in Pittsburgh, I saw what was possible at the bleeding edge of vision systems. In high noise and vibe environments where you have lots of vibration, a car moving at highway speed has to deal with a lot of, there's no fixturing that you can do really to prevent bumps, right? And, you see what software is possible to control or to make sense of a deeply unstructured world. And you also get exposure to all of the brightest minds of computer vision of how do you package that in a way that works, on the edge, right? And then when I went back to, I would catch up with my college friends, or I would go on vacation and meet up with some former coworkers of like, hey, this is what's possible for self-driving cars. How is, the vision that you're working with at your manufacturing site? And the answers that I got were, oh, yeah, we're using the exact same cameras that we had 10 years ago. Or, oh, yeah, it's great. We have, way fancier cameras. It's like, well, is the software any better? No, it's still crap.
Wow.
But now I've got a camera and a big TV that I can look at. And so that was sort of the core nugget that was just turning away at my brain. And the start of Bucket was, let's take these vision systems and let's see how we can apply it to a domain where you can measure your impact. You can actually say, okay, let's reduce the amount of operator input, or even better, let's reduce the amount of rework that needs to go on inside of manufacturing processes, which gets me super stoked.
Yeah, interesting. Yeah, so you could see stuff that was either fundamentally broken or just not addressed, just stayed in its old state as everything else had progressed along the way.
Exactly. Yeah. And so, there's a lot of, we could sort of talk about the economics of where this happens. But one of my favorite things is, have you heard of like AOI machines, automated optical inspection? We as a human society have put a lot of time and energy into visually inspecting printed circuit boards, which is great, right? If a printed circuit board has a failure, that could lead to a fire, that could lead to an electronics failure, lots of different, deeply bad things that you don't want happening. And so a lot of software products are focused on printed circuit boards. And my insight from my time at Michelin was, that's not a printed circuit board, that's a tire, right? And the answer is, hey, do you guys have optical inspection? Yes. Do you have algorithms that work well for tires? Absolutely not. We're trying to make things that are built for PCBs work on, the enclosures that go inside of your circuit boards. And so that's sort of the key gap of you really, really need to be a deeply crazy person to say, I want to build something for the water bottle, the water bottles of the world, the door handles inside of automotive, but these are huge problems.
Huge problems, a huge need. Yeah.
Exactly.
Yeah.
Exactly. Yeah.
Yeah. I guess having that perspective and awareness, right? So everyone else can overlook that so easily and just be like, oh, I'll do what everyone else is doing, or I'll do the more difficult, intricate thing that it makes sense for every part of that chain, right? From a product standpoint. Yeah.
Exactly. And there's another really fun aspect of this element is, 5 years ago, the cost of a camera itself would have been deeply prohibitive. But as we go further and further, if you really stare at it like industrial sensors, it's the same like Sony imager that's packaged in a webcam. So again, right, the cost has really come down. I'm not advocating for people slapping webcams into their manufacturing facilities. USB-C is not a fun connector to deal with, again, in high noise and vibe environments. But it means that, you can get more clever with your types of sensors if you are careful about how you think about what those things are doing and you build a good software product.
Nice. When you started, were there any assumptions that you made that have turned out to be completely wrong with the direction or the product?
Yeah, that's a great... so when I started, I was really, really passionate about medical device manufacturing. I thought surely medical device is something that is made in high cost of living areas where quality is a deeply important aspect of things. and there's lots of scrap in your medical device manufacturing. Surely this is a great target market. And the reality that I was sort of punched in the face with is any medical device manufacturer on the planet does not want to trust a like 5-week-old company with at like, oh no, just let me duct tape this camera, it's really cheap, right? Like, no, that's a new sensor stream that we can be audited with in the event of a lawsuit, right? Like, no, we're not going to trust you. Two, like, speed is not something we really care about. Accuracy, yes, but there's a whole certification process, and so that was a fun learning. It felt really exhausting at the time, but a very important like 3 days in Boston, sort of like driving around to different companies before I realized, oh, okay, let's change tack here.
Okay, we won't do that.
You gotta get out there. Okay, there's lots of other like, what about toys? What about
water bottles?
Yeah, exactly.
So at a high level, how does Bucket system actually work in a live factory environment?
Yeah, so the bucket system is incredibly simple. What we do is we take the CAD file, the engineering drawing of the component or assembly that we're inspecting, and we turn that into a huge data set to train a vision model on what it's supposed to be, what is good and what is bad. And because we're using very low cost hardware, that gives you the ability to do inline inspection on your manufacturing environment, whereas before you were using, your options were put a human being in the middle of my line or a really expensive and really fragile camera that's like deeply inaccurate, or wait until my end of line where that's the most expensive point to say, geez, we missed a step at step 2, so now we have to scrap this whole thing or we have to disassemble it and move back. By starting with that design file, you don't need to babysit a camera to train things, and you can rapidly change what your definition of good looks like, and you can deploy to many, many, many more stations in parallel instead of a very serialized rollout of camera systems, which is really exciting to me.
Yeah, that is. It's super interesting. Was there a particular technical problem that you've had to solve for so far that was like the hardest hurdle to overcome, like perception or manipulation, reliability? I don't know.
Yeah, it's the simulation itself is the core. It's the sim to real gap is the challenge. Yeah, because again, right? There's lots of research around simulating printed circuit board failures, but it's still incredibly challenging. Like your water bottle, like if you hold your water bottle up to the camera, right? It's very, very difficult to say, is that a shadow on my cap or is that a burn mark? Because a burn mark is something that I want to exactly, right?
Like, dent. Yeah,
you as a human can sort of start to pick that up, and you could do that manipulation. You could sort of hold things up to the light, but it's very, very difficult to train a regular robot on. Oh nope, you told me that I'm supposed to look for this shade, and now all of a sudden there's a different shade because it's winter and now it's slightly darker in my factory. So oh my gosh, it's 100% defect. No, that's crap. That's by building enough of a simulation of what good and bad looks like in different conditions, all of a sudden you can trust your system more. You could do that in line. You don't have to wait until final inspection and pay someone $30 an hour to do a deeply miserable job of like water bottle double checker. Like these are real. Yeah, exactly. Yeah.
A lot of robotics companies do so well in these demos, right? And we're seeing, I think right now it's, I don't want to say clickbait, but it's very interesting and very cool that you see these demos and they make for great videos and stuff like that, but then they fail in production. How are you guys thinking about this real world robustness from day one and how that feeds into how you build?
It's all I think about. It's really fun to come from autonomous vehicles where, your demo is on the public road, where you have an infinite number of actors around your vehicle who did not make a conscious decision of saying, like, yes, I will sign this waiver and enter, right? Like, you can't screw it up. You can't say, okay, let's take that back when you're operating around baby strollers on the public road. And so, at Bucket, we're constantly saying, like, you really need the mental illness of, like, treating this like an autonomous vehicle where you can't mess this up to do this right. And it just so happens that it's a significantly easier problem to determine if your door handle or your aircraft component is potentially defective than doing all of that processing and then saying, great, okay, are we clear to proceed? Can this vehicle move forward? Take all the existential dread out. Still deeply challenging, but it helps you scale. And there's lots of fun. We could have a whole conversation about robotics demos and, like, the things to look out for as you're watching videos, that pop up on, like, Twitter or whatever.
Share a bit. Yeah, high level. I'm curious. What should I look out for?
Okay, so this is something that we learned during COVID, but the number one thing that I tell everyone who's working with camera systems in, like, automation or robotics applications is get yourself an analog clock. Get an analog clock and put it in your frame. Because with an analog clock, you know what that count looks like. You can determine, hey, did my camera stream freeze? You can determine if there's, like, any sort of, like, artifacting or skipping, right? Hey, wait a second, that went backwards in time for one frame, then forwards in time. You can also tell if a demo is sped up. Yep, exactly. Shadows are another good one. If you see a window, right, like, watch how trees are moving is a good thing to look for.
That's really cool.
And the analog clock is important because, you might get the weird artifacting effect from, a TV or a digital clock. And that's not really important. You don't want to focus on that, right? Like, that's just, then all of a sudden people are like, geez, they're doing something weird. Now that's just how frequencies work, right? Like, you just caught a weird knife's edge. Yeah.
Interesting. Okay. That's really good advice. You heard it here. For all the founders that are creating these demos and these videos. Yeah, that's a good thing to throw in there. You mentioned earlier about, when you were looking at the medical devices and stuff like that manufacturer. So that was a bit of a learning curve, the cost side of it and the speed. Now, with the direction that you've taken and where you're, doubled down your focus is, how do you balance that speed versus accuracy versus cost? Like, is there something that actually matters most to customers that you've found, or is it just like a philosophy internally that you've kind of developed?
Yeah, it's such a good, so our system, by working from the CAD file, right, allows you to do things like scale up, whereas before you have to make this decision of, I could build one quality station for $100,000 or I can do 10 for 10. And so if you're a plastics facility with 100 machines, right, now all of a sudden you can do inline automation a lot faster and accurately, right? You have that digital record. The flip side is also true, which is, we have defense customers where a total program may have 25 assemblies, boats or whatever. For the entire lifetime, we're going to build 25 boats this year. But we don't want to use real images of our facility because that's something that is secret, right? We want to be able to build a vision system. We have human operators who are very expensive to train and even more expensive because they're in this defense environment. Why are we paying them to, like, rub their hands on the side of the boat, right? Is there any way to automate that deeply manual, deeply crappy inspection job? And the answer is yes, right? It's, okay, chuck in your CAD file, load in your spec on what you're looking for, and then boom, you're off to the races. And maybe that's a person who's carrying that camera down the line, but that's a much easier task, and then you can offload that and sort of go back to doing the things that you're really, really good at in quality of root cause analysis of like, why did a defect happen, and free up that like deeply crappy paperwork and hey, I don't know, does that look like a defect? Let me call somebody else, and now let's call a third person, and that's time wasted.
Time wasted, yes, of course.
Yeah.
Talking about your customers, I'm curious who, if you have like a ICP or right now, or who isn't a good customer for you guys, who's not an ideal customer.
Yeah, so our ICP is manufacturers who have a automation bottleneck around their inline quality. And they have found that there's an ambiguity in their inspection criteria. The concept is a saleable defect, where like one of our, one customer that really springs to mind is that defense customer down in California, where boats are absolutely insane. Like from a geometric dimensioning and tolerancing perspective, you can be off by like plus minus 6 inches on a hole, and that's perfectly acceptable.
Really?
Yeah. No, it's crazy. It's
so big.
It's actually crazy. Yeah. Because boats are big.
Yeah, I guess. Yeah, that's true.
No, exactly.
But
exactly.
crazy,
Yeah.
6 inches. Yeah.
Yeah. But what's not acceptable is, your capstan that's installed backwards, right? Because you're doing this on a big crane and it gets twisted around or something like that, right? Really, really expensive operations, or even worse, you have a bunch of surfaces that need to be painted and something is missed because, it was 4:00 on a Friday and second shift didn't pick that up. Really, really, really expensive rework operations that you catch at final, inspection that should have been caught before you were released out of your paint booth. That's a trend that we hear a lot. Or, again, those higher volume manufacturers where, we're hand assembling something, and the types of defect that we're getting is we have 5 quality operators and they all have 5 different definitions of what bad looks like, and I'm trying to I'm tearing my hair out trying to figure out what good and bad actually means. Those are the fun challenges.
Interesting. Yeah. What objections do you hear most often when you're selling into this space?
Yeah. Oh man. Okay. Actually, I was just on a call. It was like playing bingo. It was a lot of fun. No, automation is difficult. Automation is scary. And for our customers, what's worse than automation is that being able to trust that this robot is not going to, tell me that everything is a defect. That's a real challenge inside of vision applications. We live in a continuous time system. Everything is defective by some definition if you stare closely enough. If you take an electron microscope to anything, I'm sure there's some thing that is off nominal. But what's a saleable defect is the really important thing. What's a level of nuance that it's pretty easy to train a human being to do for 30 minutes at a time. Those are the types of more complex tasks that we go after, and we get a lot of objections of I've tried a vision system before. It took us 15 months to train, and then that operator left, and we had to scrap it. It's like, brother. Yeah. Well, no. And the answer is okay, yeah. Okay, so in 15 months, you collected 10,000 samples, and by using simulation, how would you like to generate the same number in 6 minutes? By the end of this call, we will have generated 10 times more images, and that's your baseline, right? Is that interesting to you?
Easy sell, it sounds like.
Yeah, exactly. We just heard, we spend 4 days doing acceptance testing, and we'd love to get that number down to an hour. And our answer was like, how would you like 15 minutes, right? Like, not even an hour. That's already too much, because that's still an engineer plus an operator. That's not acceptable. Let's build to what you can do. Yeah.
It sounds like proving ROI in a way that actually gets deals done is kind of, I don't want to say easy, but is a main, because you touched on like the time waste or the multiple people involved, or obviously issues with quality. If that actually goes to scale, it sounds like you can highlight ROI within these conversations.
Exactly. It's getting to that conversation is the challenge. There are huge players in the vision space, like the Keyence Corporation or Cognex. Keyence is valued at like 110 billion US dollars. Yeah. And they sell amazing products, and it's great. But, again, there's just edges to quality where their answer is work with a systems integrator, and, maybe there will be something bespoke. And the crazy part about manufacturing is, even 0.1% of vision problems is still a multi-billion-dollar opportunity.
Yeah.
And so it's talking to those people who have been burned in the past and saying, no, I actually have built this system for you. And then once you get in, it becomes very easy. But it's that, I tried cameras before and they absolutely burned my butt. I had a Thanksgiving where somebody gave me a call and I root caused it because the lens cap was on, right? Like, yeah, I hear you. I've done the same thing. That's why, have you seen our lens cap detector? Like, I get really excited if we could tell when the camera is blurry. Let's build to the types of operations problems that we've seen before and make sure they never happen for our customers.
Love that. Do you find that customers are buying tools like this for a specific reason, whether it's cost saving or labor shortages or something else entirely different, or is everyone completely looking at something different?
Yeah, it's really fun. It really does come down to two things. One is a labor shortage problem. Being a quality inspector is a deeply miserable task. It sucks. It's really hard. And then the other side is we have customers who are really reshaping their supply chain since the pandemic, and now we're really seeing the impact on tariffs of onshoring manufacturing. Of before we were getting our injection molded equipment from Canada, but now we're bringing it in-house, and oh my gosh, I have to stand up a quality team to now do that acceptance. Like, this is really hard. This is deeply, we're now making drone motors at a volume that we haven't done before. And wow, oh my gosh, there's a lot of components to a drone motor. This is a really crappy operation if I have to pay someone California wages to like stare at all of this. Oh, wow. It's those, it's the quality is a great sort of place to be to understand like macroeconomics of or global economics. It's a lot of fun.
Interesting. I'm sure that a lot of things have like surprised you. You've learned a lot about just selling into this industry in general, like you're talking about the macroeconomic side of it.
Oh my gosh, yeah. It it really was so funny. We went through the Y Combinator Accelerator in the summer of 2024, and tariffs happened in January of 2025. And so
great timing.
Really no, exactly. But it also meant that like when we were going through YC, of like who actually does plastics manufacturing in the US? Like, or okay, yeah, defense might be kind of cool. Tariffs happened in January. We won our first Air Force contract in February of 25, and
wow.
we just submitted for another like 2 hours ago. It just keeps
Good luck with that one.
Thank you.
Well, let's talk about building the team now, because obviously early stage robotics teams are brutally hard to build, regardless if you're more software focused or hardware. It's just, I guess, the industry and the application. It's very unique. I found anyway. Maybe I'm biased because I'm in the hiring space, but I'm curious from your perspective, what profiles have been the most critical for you at the early stage?
Oh man, I think the number one indicator if someone is going to work well at Bucket Robotics is empathy.
Interesting. Okay.
Yeah, yeah, because again, quality inspection is a deeply, deeply crappy task, and you never get nobody ever praises you for doing your job and saying yes, I correctly let things go. But there's only ever negative outcomes for people who are in quality of like, hey, why did you let that slip through? So having empathy for how our customers are using our system is very important. It's also a trait that can be lacking in a lot of robotics companies that I only have my undergraduate degree. I'm very blessed to have, deployed robots and worked in these manufacturing environments, but I don't know more about a customer's, specific problems than they do. I'm just here to listen and say, hey, I've had a lot of shared experiences. Will this thing that I have built map to your problem? And that's, again, that's maybe the nature of like the very specific product that we're building. I would probably give you a different answer if I was saying like we're an AI lab that's building, something for in-home or something like that. That's a totally different set of still empathy, but a different kind of empathy,
True.
Yeah.
Is there anything else that you think separates a great engineer from an average one in your world?
Ooh, yeah. So we spend a lot of time talking about this internally of engineers who live not on the bleeding edge, but who are early adopters of technology. And this is something, again, that I'm very lucky for my exposure being in the Y Combinator network. If you go to a conference like Modex that's happening in a few weeks, I will run into people who are talking about things that my team has been using for like 6 months. Kind of, you know what I mean?
Yeah.
And now is such an amazing time to build a company at the size that we are and moving as fast as we are, because of things like really specific uses of agents for coding and even just design principles and understanding like where the camera cost is going or like what is happening with NVIDIA's Jetson product line. We don't want to be on the bleeding edge because the bleeding edge leads to there was a a recall on the thing. You don't want to be on the bleeding edge. You want to be an early adopter.
Yeah.
Like, okay, that's stable.
I guess there's also the danger of like being on the bleeding edge. It's kind of like, oh, squirrel, let me go and focus on this new thing now. And then let's see how we can put that in.
Exactly.
I don't know if you think about this or consciously or even curious to get your perspective, but how you evaluate people who can actually ship versus those who love like R&D prototype and like just focus and operate in that world.
Again, something I spent a lot of my career thinking about. I am a huge believer in people who will just pick up the shovel and go dig and then talk to the people who are next to them over the R&D is a deeply important aspect of pushing the boundary of technology, and I'm very grateful for companies who are like pushing the R&D forward. That's not what we're here to do. We're here to build a really big company and to demonstrate to our customers that we're helping their bottom line. And so what's funny about that is when you hire people who are very interested in just shipping and believing in the mission. We just published a paper a few months ago, or weeks ago, sorry, about our CAD-based defect detection system at the Society of Plastics Engineers conference. We're still shipping research, but that's not the point of a it's not the point of a venture backed startup. That's what
Yeah,
academia is for, you know. Uh,
true, true. Last one on hiring before I'm conscious of the time. I want to try and fit as much in as I can, but I wonder if you've had or if it comes to mind, a biggest hiring mistake or mishire lesson that you've had in your career. It doesn't have to have been from Bucket. It could have been from, previous roles or things that you've seen, but I'm always curious what people have learned from doing something the wrong way.
I have made that mistake in the past of hiring someone on paper who was a very good fit, but again, because of the nature of deployments for robot cars or here at Bucket, um, you know, one of the biggest challenges that I've seen is someone who is willing to travel to be with the customer.
Yeah.
This is huge. We sell into manufacturing, whether you're in robotics or in manufacturing or automation. This isn't a B2B SaaS product. It's not like you can jump on a Zoom call. There is always an element of that. You always want to, be remote, but the biggest success is when you can actually roll up your sleeves and be next to the customer, and even better if, you're someone who is comfortable getting on a plane wearing their steel toes and saying like, great, okay, I'll be at the facility. That's the thing to index on. And even if someone is someone who was a director at your largest competitor, or I've back in my day I've done, like, they may seem great on paper, but if there's somebody who can't get to where your customers are, unless this is someone inside of like your finance department, it's going to wind up to be, whether it's operations or engineering,
Yeah.
you always need to be able to get to where the customers are. So that's my piece of advice for all the hardware dorks out there.
It's true though. Since COVID and everyone's like over-indexed on remote working or hybrid working, I think people have come less willing to travel and be in front of people. But I always see it so important in the hardware world anyway, in general. But obviously, if you're operating, like you say, in manufacturing, these facilities aren't going to be right in the middle of the city that you live in. You're not just going to jump in your car and go 20 minutes down. A lot of them are, you're doing that or data centers or whatever, they're all in like remote places.
Yeah, and that's my other piece of advice too, is hire near like good airports, because exactly to your point,
Yeah.
that's just adding. Yeah, if your customer is in the geographic middle of Montana, and you're hiring somebody who is in the geographic middle of Texas, how many flights exist between those two, right? Like there's no direct, so that's already, might seem great on paper, but let's try to think through it. It's funny, I actually send most of our San Francisco based team to the East Coast. There's points where it's easier to get from SF to an East Coast customer than our employees in Pittsburgh.
Really? Just because of the connections? Yeah.
It's a big airport. There's a lot of weird direct flights.
True. Yeah, I guess that's a good point. Yeah. I want to get your perspective on the industry in general right now. You've obviously been in various aspects of it, and I know you're very plugged in from the events and just your network, and we've obviously met in person at a few of these things as well. Where do you think people are overhyping robotics right now?
I'm showing my biases here, but the operational aspect of deploying a successful robot product is something that I see hand waved away quite a lot inside of the robotics and venture ecosystem of, look at this demo of 100 robots acting in sync. This means that we can have one robot deployed in 100 locations by the end of next month. and that's deeply not the case, right? There's a lot of operational hellscape and learnings that come from deploying things at scale, one inside of dense areas, but then also as you spread. And so those are the things where people say like, oh yeah, at this rate, we're going to have 1 million humanoids in, the state of South Carolina by the end of next year. It's like, I would love to live in that world. Are you kidding? There's lots of really crappy tasks, but like if a humanoid de-energizes and there's like a 1% chance of that happening, that's like 100 pounds that's gonna like fall onto somebody's hip. Like, have we thought through this? Like, you haven't given me an answer on what your plan is for like when an over-the-air software update fails. Like, what's going on here, guys?
Right. Yeah, and you're not going to get that unless you incrementally improve and get to that point of like, you're not going to go overnight or in a year to the 1 million deployed.
And even if you can manufacture them, being wrong. Exactly. Setting aside,
it's like the actual deployment.
Setting aside like thermodynamics and like exactly. We can
On the flip side, is there any area that you think is underestimated or underbuilt right now?
Ooh, I am increasingly excited by the sort of lightweight and the precision of what used to be called cobots, but are now just more and more being co-opted as just robotics. I'm getting very, very excited by that. If you wanted to use a cobot 3 years ago, it would have cost you 5x the cost that it does now, and it would have been like deeply imprecise unless you buy the really, really expensive kind. And now these are, you and I could 3D print out an SO101 arm and get the same level of precision for something that costs, $15,000 from a 3D printer. And that's really enabling people to shake out those operational beats very cheaply and grow their companies. And so I'm really excited to see that proliferate.
Do you think that we're headed towards full autonomy in manufacturing or like a hybrid human robot model long term?
Oh, super hybrid human. The human mind is capable of so many just truly amazing things that, we as a species probably can't program into like a lights out manufacturing. Let me say, lights out manufacturing is certainly possible in lots of areas and in lots of parts of the world. Specifically looking at very developed nations, I actually think that hybrid manufacturing is what's going to enable the best of everything that we need, whether it's, rockets that are going to take us back to the moon, or very, very high quality toothbrushes, or whatever it may be. Saying that we're going to have like raw material comes in and then deeply bespoke stuff comes out, I don't think that's possible without humans. And that's a great outlook for the economy and for interested people and for, advancements to make the really manual and really high automation stuff even more automated as time goes on.
Awesome. Well, we're almost at time, but I always like to get some founder reality perspectives for our listeners, because we have a lot of like first time founders here. I'm curious, has there been anything harder than expected as being a founder and being on this journey? And then likewise, anything easier than expected for you?
This is much easier than my last few jobs.
Really?
Oh my, well, from a perspective of, again, my previous roles were in reliability and integration for autonomous vehicles. So anytime your Slack went off or there was a pager duty, your first thought needed to be, oh my gosh, did we just run somebody over? Did we just get hit? Yeah. Is everybody okay?
Stress.
Oh,
Yeah.
okay, there was
Wow.
a weird Wi-Fi problem. Like, yeah, there's lots of stress with running a company, but like
Yeah.
nothing, and you want to take that level of seriousness for our customers. But that's not the first thing that we think about when we're building human augmentation systems of, it's an iPad that operator presses a button, camera takes a picture, and then it says like good or bad. So that's the
Less
easier
risk.
side.
Yeah.
Yeah, yeah. What's harder is, it's a very lonely experience. It's very isolating, and so finding a community of other founders, whether they're online or in person, and finding founders who are more successful than you, and really keeping up with talking to them and understanding what they're doing is hugely helpful.
Yeah. Yeah. So was the YC experience helpful for you in that respect, being around like-minded people?
Absolutely phenomenal. Yeah, it was the best professional experience of my life. And again, it sounds crazy, but in the summer of 2024, the joke was there were as many robotics company in our batch as all previous batches of Y Combinator. And so there were very few people who knew how to give like advice on robotics. But there were people who had built huge companies, and hiring is a universal problem, whether you're working in robotics or software for banks. Landing those first customers, knowing what a good logo looks like. All of these are things that you need to think through, and that's an amazing community for help with that.
Love that. Yeah, I remember that cohort. And then similarly this year it was, or the last one was just more AI companies than they've ever seen in one go. So it's pretty cool.
And it's so cool.
Yeah. Before we go, what does Bucket Robotics look like in the next 3 to 5 years if everything goes right?
I like to think of the moment that we're in for quality systems as the cloud computing revolution. When we talk to our customers, they already have they either have like negative amounts of instrumentation, 0 cameras, or they're cameraed to the gills and it's deeply unstructured data.
Yeah.
And so, what I see similar to the explosion in cloud computing, going from deeply individualized work machines that are deeply powerful to saying, no, we can actually do a lot more with a lot less in terms of hardware cost, your upfront cost, and really help enable customers to move faster. That's how I think about this. We are a platform that enables things, and capitalism says that Intel and Sony are going to be way better at building cameras to enable us. So just buy a camera through us. But it's that core software, it's that core understanding that we are enabling manufacturers. And in 3 years, I want to be the gold standard for modern quality systems.
Awesome. Well, look, thank you so much for being on the show today, Matt. I really appreciate
Thanks for having me, Greg.
Yeah, my pleasure. I'm glad we finally got it sorted and got it scheduled.
Yeah,
how can our listeners learn more about you and Bucket Robotics?
Yeah, so you can go to bucketrobotics.com. Send me an email. I'm matt@bucket.bot. You can find me on LinkedIn. My last name is fairly difficult to pronounce, but I'm always there. And follow us on YouTube. We have a weirdly, I'm very proud of our YouTube channel because, again, folks in manufacturing, when I see a new problem, I go to YouTube. And so that's where I want to, explain how our system works and who our customers are for. And so those are the places.
Awesome. Well, we'll link all of those in the show notes, and I will be following along to see everything that you guys do. But thanks again. This was awesome.
Thank you, Greg. Appreciate you.